Hi, my name's Gabby, and today I'm here to talk to you about the caffeine molecule for my 2014 chem1090 vlog assignment. The proper chemical name for caffeine is 1,3,7-trimethylaxyline. The chemical formula is C8H10N4O2. It has 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms. The molar mass of caffeine is 194.19 grams per mole. It has a melting point of 235 degrees Celsius and a boiling point of 178 degrees Celsius. Caffeine is naturally found occurring in coffee beans, cocoa beans, tea, and guarana. Caffeine is personally important to me because this magical cup of brown liquid I consume every morning makes the world all sunshine and rainbows. It keeps me awake in lectures and gives me that extra energy to make it through the day. Caffeine is every uni student's best friend. Caffeine is most commonly consumed as coffee, tea, in some soft drinks, energy drinks, and products containing guarana. It is the world's most popularly used drug. Caffeine shares a number of similar stimulating traits with amphetamines, cocaine, and heroin. But just because it isn't considered as hard a drug doesn't mean it's not addictive. Caffeine's effect on the brain is via replacement of the neurotransmitter adenosine for caffeine. The brain releases the adenosine to slow down the cells in the brain and the body to induce sleep. Caffeine and adenosine have a very similar chemical makeup. This can be seen by the circled parts of the molecule shown on the picture. They both have the similar double ring structure. This is why it's so easy for the receptors to mistake caffeine for adenosine. The two molecules have complete opposite effect on the body, with caffeine making the body have temporary alertness by stimulating the central nervous system, affecting heart rate, respiration function, and altering mood. Caffeine is quickly and completely removed from the brain. Its effects are short-lived and tends not to negatively affect concentration or higher brain functions, while adenosine is put out to do the opposite, slow down the cells for sleep. The red circles show the tetrahedral shape that is formed by the carbon with the nitrogen and the 3 hydrogen atoms. The red circled nitrogen makes 3 single bonds with carbon atoms. This nitrogen has 1 lone pair and has a pyramidal shape. The nitrogen in the red circle has 1 lone pair and has a bent shape. This nitrogen bonds with 2 carbon atoms. These 2 carbons make 4 bonds, and both bonds make a tetrahedral shape. The first carbon bonds with 2 nitrogen atoms and forms a double bond with oxygen. The second carbon makes a bond with another carbon and also with another nitrogen atom and forms a double bond with oxygen. Caffeine is a tricky molecule when it comes to considering its polarity. The substance will dissolve in water. It has both polar and nonpolar components, but overall is considered polar. The bond between hydrogen and carbon are nonpolar. The atom of nitrogen and oxygen are more electronegative than the carbons present, thus pulling the electron density away from carbon. Caffeine molecules have intramolecular forces including hydrogen bonding, dipole-dipole, and London dispersion forces. Thank you for watching my chem1090 vlog on the caffeine molecule. I hope you enjoyed it.